Hey, it's Mr. K, Physics 30, Unit C Review, question 4. So, you see this thing? You see a Michelson type experiment. Now, essentially what's going on here is the light is traveling in, it bounces off a distant mirror, comes back, and then gets detected. Now, this only works if the time that it takes for the light to travel all the way out to this distant mirror and return is the same amount of time it takes to rotate one segment of the mirror. So that means 1 rotates to 2 or 2 rotates to 3. So that is, in this case, because it's an 8-sided mirror, that is 1/8 of a rotation. So now looking at how we're going to calculate this, they're asking for the frequency of the system itself. So a couple things, I'll kind of sort this out a little bit. Well, we remember that period is 1 over the frequency. So we want frequency, we bring it back to this relationship here, that speed is equal to distance over time. We know the distance is going to be 2 times the distance going out to that distant mirror and back. So I've represented that as 2d. And then in terms of the time, well, we don't need it to go a full rotation of this mirror. We only need it to go 1/8. That 8 is specific to this question because it's an 8-sided mirror. So my time is really t over 8. Now in terms of the algebra, if I replace that, I'll just do it down here. V equals 2d. Instead of the period, I can put in 1 over f. I've got 1 over 8 already. And then we should know that if I've got a fraction on the bottom, that denominator can actually be presented on top. So really this becomes 8 times 2 times d times f. Or in other words, 16 times that distance times the frequency. Okay, looking at the algebra, we know the speed of light. We know the speed of light is 3 times 10 to the 8 meters per second, so that is a known. We know the distance. We can just put in 3 times 10 to the 8 meters per second divided by 16 times the distance. It's important to convert the distance to meters because our speed is in meters, and that will give us our hertz. Thanks for tuning in.